Given that x to the 4 y to the 5 plus y to the 4 x to the 5 is equal to 810, and x to the 3 y to the 6 and y to the 3 x to the 6 is equal to 945, then what is 2x cubed plus xy cubed plus 2y cubed? So generally, when we have a problem like this, we either need to apply some special factoring trick to solve for this, or we need to just brute force for x and y. So brute forcing for x and y seems pretty impractical here, as we're dealing with some pretty high powers and we're not allowed to use calculators. So I'm thinking to go with the first solution. So we're going to try and factor 2x cubed plus xy cubed plus 2y cubed. Now if you just try doing that, I'm sorry to tell you, but there actually isn't really a way to do this. But however, we do know that 2x cubed plus xy cubed plus 2y cubed is in fact equal to 2 times x cubed plus y cubed plus xy cubed. That isn't much, but it will be very helpful for solving this problem. So all we need to do is solve for x cubed plus y cubed, or x cubed and y cubed, and also x times y. But yeah, let's start solving the problem. So let's first look at the first equation. X to the 4, y to the 5, plus y to the 4, x to the 5 is equal to 810. Now, normally I would try and factor out x4, y4, but I'm looking at the second equation and I see that I can't factor out an x4, y4 there. So I'm going to first start with x3, y3. So x to the power of 3, y to the power of 3 times xy squared plus x squared y is equal to 810. Also, looking at the second equation, we can factor this as x cubed y cubed times x cubed plus y cubed is equal to 945. So now, looking at this, I noticed something. Well, if I can solve for x cubed y cubed, I can then solve for x cubed plus y cubed and vice versa. Now, dividing both of these equations gives us xy squared plus x squared y over x cubed plus y cubed is equal to 810 over 945, which is also equal to 6 over 7. Now, as long as x cubed y cubed is not equal to 0. Now, let's prove that x cubed y cubed is not equal to 0. If you're running low on time, you don't have to prove this, since it's pretty obvious, but for the sake of thoroughness, let's just prove that x cubed y cubed is not equal to 0. Now, if x cubed y cubed is equal to 0, that means that x cubed or y cubed is equal to 0. And this means that either x or y is equal to 0. Now, since x and y are interchangeable in these formulas, let's see what happens if x is equal to 0. Well, that will give us 0 is equal to 810, and so we've reached a contradiction, and so this is fine. Now, moving on, we can then continue to factor. We have xy times x plus y over x plus y times x squared minus xy plus y squared is equal to 6 over 7. Now, cancelling out the x plus y gives us xy over x squared minus xy plus y squared, as long as x plus y is not equal to 0, or as long as x is not equal to negative y. So now to prove that this is true, we can substitute x is equal to negative y into the first equation. So we have y to the power of 9 minus y to the power of 9 is equal to 0, and since 0 is not equal to 180, this is also fine. Alright, so now cross multiplying gives us 7xy is equal to 6x squared minus 6xy plus 6y squared. And now moving the 7xy over to this side gives us 0 is equal to 6x squared minus 13xy plus 6y squared. So now let's move this to the top and continue solving. So this looks an awful lot like x plus y all squared. So we want to get 12xy, so we can turn this into 6 times x plus y squared. So adding 25xy to both sides gives us 25xy is equal to 6x squared plus 12xy plus 6y squared. Now dividing both sides by 6 and xy gives us 25 over 6 is equal to x plus y squared over xy. So now let's isolate x plus y. So we have 25xy over 6 is equal to x plus y squared. Now taking the square root of both sides gives us 5 root 6 over 6 times xy to the power 1 over 2 is equal to x plus y. And now let's look at the first equation. We have x to the 4 y to the 5 plus y to the 4 x to the 5 is equal to 810. And so x to the 4 times y to the 4 all multiplied by x plus y is equal to 810. And so now we have x4, y4 times 5 root 6 over 6 times xy to the power of 1 over 2 is equal to 810. And also that xy to the power of 9 over 2 is equal to 810 times 6 over 5 root 6. Now 6 over root 6 is equal to root 6. So we have xy to the power of 9 over 2 is equal to 162 times root 6. So now let's take the prime factorization of 162. So 162 is equal to 3 to the power of 4 times 2. So now squaring both sides gives us xy to the power of 9 is equal to 162 squared times 6. And now 162 squared is equal to 3 to the 8th times 2 squared. So now multiplying both sides by 6 gives us 3 to the 9 times 2 to the 3. And since 3 to the 9 times 2 to the 3 is equal to xy to the power of 9, we know that xy is equal to 3 times 2 to the power of 1 over 3, or xy is equal to 3 times the cube root of 2. So now I'm going to move this to the top, and then we're going to continue solving. So now taking the cube root of both sides, we got x cubed y cubed is equal to 27 times 2, which is equal to 54. So that's really helpful, because we know that xy cubed is equal to 54. So we have this is equal to 2 times x cubed plus y cubed plus 54. So now finally, let's plug this into the second equation. So we have x cubed y6 plus y cubed x6 is equal to 945. X cubed y cubed times x cubed plus y cubed is equal to 945. 54 times x cubed plus y cubed is equal to 945. X cubed plus y cubed is equal to 945 over 54, which is also equal to 35 over 2. So we know that x cubed plus y cubed is equal to 35 over 2, and therefore 2 times x cubed plus y cubed is equal to 35. So we have 35 plus 54, which is equal to 89. And that is our final answer. And we are done. So yeah, that's about it. Thanks for watching. Hopefully you enjoyed, and hopefully I'll see you next time.